Welcome back to ICSE MathGuru. Today I am back with one more lesson, and today's lesson is on factorization of polynomials. Yes children, today's lesson is on factorization of polynomials. Yet again a very simple lesson from Algebra Unit 2. Okay, you can expect close to 3 to 6 marks from this lesson, 1 in objective and a 3-mark question, or sometimes lucky enough you get a 3 and a 4-mark question from this particular lesson, factorization of polynomials. Okay, again children, believe me, it's a very simple lesson. So to understand the concept completely, watch the video till the end, because I am going to tell you all the techniques on how to factorize a polynomial, how to solve the given sums with the conditions given. Every single technique, every single tip I am going to discuss in detail. So watch the video till the end, and also don't forget to like, subscribe and share to ICSE MathGuru, and hit the notification bell to get updated with the upcoming videos. You must have seen that I have been continuously posting videos according to the syllabus of Standard 10, preparing y'all and helping y'all to prepare for your 2024 board exams. So together let's rock and hit the bullseye, and if you travel with me in this journey, I can assure you of a very good score in your ICSE board exams. So without much delay, let's get started with today's lesson, factorization of polynomials. Now if you observe carefully, this lesson is divided into two main parts. One is factorization and the other is polynomials. All of you have done factorization at one point or the other, and all of you know what a polynomial is. Now together, what is that we are going to learn in this lesson. Children, what is factorization? So if you are asked to factorize any polynomial, can you factorize? No, right? Because if you haven't learned this lesson before, okay, there must be some of you who have already learned this lesson. In that case, the answer could be yes. But if you are hearing it, factorization of polynomials, for the first time, then you may not be able to factorize a given polynomial because we don't know the conditions of it. Now, but if I ask you to factorize any given number, say suppose if I ask you to factorize 12, can we factorize 12? Yes, right? You know how to write factorization of 12. 12 is the product of 2 and 6. Again you write the 6 as 3 into 2. So you can write it as 2 into 2 into 3. That is factorization. Now if I have to show it to you all, children, factorization means, one second, let me choose a color. Yeah. Factorization, this term factorization, there is a difference between factorization and finding the factors. Now if I ask you to factorize 12, 12 is written as 2 into 6, or you can write it as 4 into 3. Choice is yours. Again this 6 can be written as, or should be written as rather, 2 into 3. You will have to write till a point where you cannot factorize it further. This 2 cannot be factorized. Maximum you can write it as 1 into 2. So you have to reduce it to prime factors. Why prime factors? Because a prime number has a number in itself only as the factors. So 13 is a prime number. Why? Because we cannot write any factors of 13 except for 1 and itself. Such a number is a prime number. So we reduced it to prime factors. This is what is called factorization. Now if I ask you, what are the factors of 12? Factors of 12. Children, we all learnt as a child, factor, the number and 1 both are factors, and then you write the other factors of 12. So the factors of 12 will be 1 and 12. So in between 2 is a factor of 12, 3 is a factor of 12, 4 is a factor of 12, 6 also is a factor of 12. So these are the factors of 12. Did you see the difference between factors and factorization? This is very important. As we proceed further, I am going to tell you where you lose a mark for a very simple error which you can't even dream of. So children, please follow these small tiny instructions. The problem is with most of the children, they think that I am not asking you to follow me. There are so many super mentors who have been teaching over the years on this platform. You have so many mentors at school, you have your personal coachings, whoever it is. Do listen to their instruction. The main problem with the student community is आधा सुनते हो. You listen only half and the other half you assume. Do not ever do that. So there is a fine line of difference between factors and factorization. So please be watchful. Factorize, we wrote it in the product. Factors, we separated the factors by a comma. Okay. This we will again learn further as we proceed into the lesson. Now, what is a polynomial? Here again, children, most of you have a problem. So, what is a polynomial? You have learnt as a child that if an algebraic expression has one term, it is called a monomial, two terms, it is called a binomial, three terms, it is called a trinomial, more than three terms, it is called a polynomial. But there is some other specification also for polynomial, which some of you, I said some of you might not have focused. Okay. Now, can you differentiate between, now tell me, is this a polynomial? Please do write in the comment, is this a polynomial? Yes or no? X cube minus x plus 1 by x, or I will make it x square plus 1 by x. Is it a polynomial? Yes or no? So, if you consider it yes, all those who thought it is a polynomial, children, please be careful, it is not a polynomial. A polynomial only has a positive index, positive, remember like that, positive index or positive exponent or positive power. A polynomial has only a, keep focused on this positive, at least it is for an idea, right, that it is positive. If it is a multinomial which has more than 3 terms, then you need not bother. So that is the difference between a polynomial and a multinomial. So what's a polynomial? Now can you all tell me what is a polynomial? I just now explained, now tell me what is a polynomial. Can you define a polynomial? It is an algebraic expression. Think. What is a polynomial? It is an algebraic expression. It has how many terms? It has more than 3 terms. What is the other specification? That the power of the variable in the polynomial should be dash. What it should be, children? It should be positive. So, did you get what is the meaning of a polynomial? A polynomial is a algebraic expression, okay, which has more than 3 terms, okay, and the power should not be a negative. So, it could be, even a monomial is called a polynomial, but polynomial specification, if it is one term, you give it a tagline that it is a monomial, but otherwise everything together is called a polynomial. Here you have 2 examples there, one which has 5xy square minus 3x plus 5y cube minus 3, and the other which has 3xy to the power minus 2, and the other one is 2 by x plus 2. Okay, I will write this 2 by x plus 2. Now, of these 3, which is a polynomial and which is not a polynomial? It's mentioned here that the first example is a polynomial. Why? Because every power, because exponent is what did I ask you to remember? Polynomial is positive. The first PO, focus on that. Polynomial is positive. So, exponent is positive, therefore, it is a polynomial. Now, coming to the second example. The second example has 3xy to the power minus 2. Again, here the index became negative. And 2 by x plus 2, if you want to write it in a linear form and not in the fractional form, it is 2 into x plus 2 whole to the power minus 1. You have learnt in indices, right? that 1 by x is equal to x to the power minus 1. So, this is again a negative index, negative power or a negative exponent, therefore, it isn't a polynomial. So, did you understand the difference between a polynomial and a multinomial? So, what is a polynomial? It is an algebraic expression of terms with each term consisting of a real number multiplied by a positive power of variable. The variable could be x, the variable could be y, it could be some a, whatever it is, that is what is a polynomial. So, let us see the definition of a polynomial. So, a polynomial is an algebraic expression of terms with each term consisting of a real number multiplied by a positive power of a variable, such as, there are some examples given, 2x cube, 7x, whatever it is. Okay. So, now in general, how do you write a polynomial? Children, if you understand in terms of numbers that you are aware of, it becomes easy. If it is a, n, x and all that, it gets really confusing, but you have to know a little bit of that also. That is the reason first I have given an example and then showing you the expression in the form of a n and all that. An expression in the form a n x to the power n always start from the highest power and come down slowly to a constant term. Now, if you have a constant term, say suppose I am writing one example, say 5x power 5 plus 4x power 4 minus 3x power 3 plus 2x square minus 1x and where is this minus? Okay, minus 1x plus 7. Okay. How many terms it has? 1, 2, 3, 4, 5, 6 terms it has. It is not a sixonomial or anything, children, it is a polynomial. So, according to the definition, is an algebraic expression of terms with each term consisting of a real number. We have a real number multiplied by a positive power of a variable. The variable here is x. Okay. Now, we always have to write it in the decreasing order of the power. Now, what is the constant here? The constant is 7. Okay. 7 is x to the power 0. 7 into x to the power 0. Children, again you have learnt in indices that anything to the power of 0 is 1. Anything to the power of 0 is 1. So, as I told you, it should go in the decreasing order of the powers. Not necessarily you should have a sequence. Sometimes this could be missing, sometimes this could be missing, but in the decreasing order of whatever powers are there. Okay. So, the last power becomes 0. Now, what is the degree of a polynomial? Degree of a polynomial is the highest power in that given polynomial. So, for this particular example that we have taken, what is the highest power? The highest power is 5. The highest power is 5. Suppose I am writing this polynomial as, I will clean this off, I am writing this polynomial as 5x power 5, just a moment, okay, yeah, 5x power 5 y square minus 4x power 6 minus 3x cube. Okay. Now, what will be the degree of this polynomial? The degree of this polynomial is the sum of the powers. Whichever term has the highest sum of the powers, if it has two variables, you have to add up the powers of both the variables and that power will be the degree of the polynomial. So, 5 plus 2 is 7. So, the degree of this particular polynomial is 7. Is that clear? Now, so an expression of the form a n x to the power n plus a n minus 1 x power n minus 1 plus a 1 x plus a 0 is a polynomial in degree x, okay, is a polynomial x of degree n, where a n is not equal to 0, okay, where a0, a1, a2, a3, a n are all real numbers and n is a non-negative number. Why is n a non-negative number? Because degree cannot be negative. The degree of a polynomial cannot be negative. Please keep this in mind that the degree of a polynomial cannot be negative. So, now instead of writing the polynomial is denoted as a function of x. It is denoted as a function of x. Functions and all you will learn in your standard 11, children, okay. But for now you right? It's just that you are giving it a name. So you are giving this entire polynomial a name as f of x, or you can also write it as p of x or g of x. Most commonly used notations are fx and p of x. Fx depends on x. Okay, fx depends on x. Is that clear? So in a polynomial where you have these terms, okay, this, yeah, a0 x bar n, an x bar n minus 1, all these are called the terms of the polynomial, and a0, an minus 1, a1, a0 are all called the coefficients of the polynomial. Children, you know what is a coefficient. What is a coefficient? Suppose if I write 5x cube, what is the coefficient of x cube? The answer, you learnt it in standard 6, coefficient is 5. The numerical coefficient, to be more this thing, numerical coefficient of x cube is 5. So that is what is a coefficient. Okay. So in an expansion where you have 5x cube, 3x square, 2x, 7 and all, the real number part is nothing but the coefficient of the variable part. This is the numerical part and that is the literal part. The numerical part is always the coefficient. Okay. Now moving on. Remainder theorem. There comes your lesson. Remainder theorem and factor theorem. These are the two subparts of factorization of polynomials, but both are interlinked with one another. Very small difference is there between one another. That is the remainder and the factor theorem. Now children, don't get carried away or worried with this term theorem. Theorem is nothing to do like your geometry theorems. It is just an statement that we are elaborately explaining. Okay. Now I will give you a very small numerical example. Always children, numbers is easy because you have been learning numbers from your very childhood. So if anything is compared with numbers, it gets into your head really very fast. So I am going to give you a very small example and with small numbers only. Now suppose 13 is there. I am dividing by 2. Now if I ask you what is the remainder when I divide 13 by 2? Most of you will say the answer is 1. Yes, because you know it's a very small number. Now if I keep on increasing the number, what to get the remainder? You have to do your actual division. Now what is the relationship between this 13, 2 and this remainder? 13 is called what? It is called the dividend. 2 is called what? It is called the divisor. 1 is the remainder, but something is missing. 2, how many times you will cancel to get the remainder 1? So this 13, can I write it as the divisor into the quotient plus the remainder? Can I write the dividend is equal to the divisor into the quotient plus the remainder? Okay. Similarly, now let us apply this to algebra. Suppose f of x is a function, that is, it is a polynomial. Take it as a polynomial 13. Okay. It is a polynomial and it is divided by x minus a. This x minus a is what? This x minus a is what? It is your divisor. So when you divide a dividend with a divisor, it is obvious that you get a quotient, not coefficient, it is quotient. Quotient, it is quotient. You get a quotient and you have a remainder. So if I have to write in simple terms, again children, only put this as your focus, okay, that your polynomial is 13, x minus a is your divisor. So this f of x, can I write it as this is f of x is what? It's your dividend. Your divisor is x minus a. And when I divide a polynomial with another expression, it is understood that you get a polynomial again. So that polynomial we assume it as g of x, and since it is not completely divisible, there will be a remainder and that remainder is r. Is that clear? Is that clear? Now if f of x is a polynomial in x, what will f of a be? See, x is replaced with a. So, if x is replaced with a, this in place of x you write a minus a into g of x plus the remainder. A minus a is what, children? It is 0. So, f of a becomes what? It is the remainder. Now, do not get confused again, the remainder is equal to f of a. I will give you a very small example for you all to understand what it is. So, you will be given a polynomial and you will be given a divisor and you will be asked to find what is the remainder if this particular polynomial is divided by so and so. Now, how did we write this f of a? How did we write this x minus a? This x minus a will be given. But how did we write f of a? You have to, if x minus a is given, children, you have to equate x minus a mentally to 0 and the value of x is what you are writing. So, if a given polynomial is divided by x minus a, the remainder is f of a. Is that clear? So, you need not learn or remember all this. Only thing that you have to remember is that the remainder is f of a. So, let us see this example to understand better. To find the remainder when 6x square minus x minus 2 is divided by x plus 2. Now, why is it written that we substitute x is minus 2? Why is it written we substitute x is minus 2? Because as I mentioned earlier, children, you have to equate this x plus 2 to 0 and x will be equal to minus 2. We have to equate x plus 2 to 0 and x will be equal to minus 2. Is this clear? Now, what is the polynomial here? The polynomial here is 6x square minus x minus 2. And what is the remainder theorem? The remainder theorem states that if a polynomial f of x is divided by x minus a, it means, implies remainder is f of a. So, if this polynomial is divided by x plus 2, what will be the remainder? The remainder will be f of minus 2. And what is f of minus 2, children? Just to replace x with minus 2. Okay. So, it is 6 into minus 2 square, 6 into 4. Children, remember, the square of a negative number is always positive, which means if the power is even, the number, the final answer will be always positive. But if the power is negative, but if the power is an odd number, you get a negative answer. So, 6 into minus 2 square is 6 into 4, 24 plus 2 minus 2 plus 2 minus 2 gets cancelled. So, 24 is the remainder. Is this clear? 24 is the remainder. One more example so that you understand it better. Okay. Now, so this example, if f of x is 6x square minus x minus 2, it is the same polynomial, is divided by 2x plus 3. Here it is not x plus a, here it is not x minus a, but this is of the form 2x plus 3, which means it is of the form ax plus b. It is of the form ax plus b. Now, equate this 2x plus 3 to 0. If I equate 2x plus 3 is equal to 0, what is the value of x? Minus 3 by 2. So, what will be the remainder? The remainder is simple. It is nothing but f of minus 3 by 2. Is that clear? It is f of minus 3 by 2. So, now if you see 6 into minus 3 by 2 whole square is 6 into 9 by 4. 6 and 4 you cancel, you get 27 by 2, minus of minus 3 by 2 is plus 3 by 2 and minus 2. Always keep brackets, children. I failed to keep a bracket, yeah, but you always keep brackets so that you do not make any mistake whatsoever. Now, if you see, here you have 27 by 2 plus 3 by 2 minus 2. Now, there are two ways for doing. Either you take an LCM and you simplify, but since you are growing bigger and bigger and you should know to do your sums with accuracy and with speed. Both are needed. That is, maths is not just sitting long hour and being accurate. You will waste your time. At the same time, doing very hurriedly and making mistakes, that will also will cause the loss of mark. What you should have? You should have accuracy and you should have speed. Both speed and accuracy are needed. So you have to find ways and means where you can finish it faster. Now this 27 by 2, 3 by 2. If you see they have a common denominator. So you know as a small child that you can add up even the numerators. 27 plus 3, mentally add what it is, 30. 30 by 2 is what? 15. So 15 minus 2 is what? 13 is the answer. So wherever possible, see for these small places where you can do your calculations really fast. So that is what is about remainder theorem. So what is remainder theorem? Let us recap quickly that if a given polynomial is divided by x minus a, then the remainder is f of a. This is the statement of remainder theorem. And when you are doing a sum, children, and if you are asked, if you are applying anything, if you are doing a sum and if you are applying it, how do you write? You have to write as when this polynomial f of x is divided by 2x plus 3, you put a comma, you write remainder is f of minus 3 by 2. F of minus 3 by 2. Okay, this is f of minus 3 by 2. It's little clumsy here. So the remainder is f of minus 3 by 2. You have to write this statement. Is that clear? So the next is factor theorem, which we will learn now itself, and you will learn the difference between the remainder and the factor theorem. So let's see factor theorem. Now, what is factor theorem? Children, there is a very close relation between remainder theorem and factor theorem. You all know what is a factor. Just use that little common sense factor of what is a factor, what happens when you divide a number by its factor is all about the factor theorem. Now, I gave an example of 13 by 2 for remainder theorem. Now, if I take the same thing and I change instead of 13 by 2, I take the example of 12 by 2. What it is? You all know that 2 is a factor of 12. So, if I divide this 12 by 2, I get it as 6. Now, if I have to write it as a relation as dividend, divisor, quotient and the remainder, how can I write? I can write this 12 as 2 into 6 plus 0. What is this 0? This 0 is nothing but the remainder. This 0 is nothing but the remainder. So, if you are dividing a given polynomial by its factor, the remainder is 0. That is what is all about factor theorem. So, if I have to write in terms of polynomial, children, just keep this 12 to 6 as I have mentioned earlier for remainder also. Just keep this 12 to 6 in your mind and it becomes super easy to understand. So, I am writing this 12 as f of x. So, f of x is equal to, your divisor is x minus a. Okay. So, you have the quotient as g of x and you have the remainder as r. But if x minus a is a factor, of the polynomial, you know that the remainder becomes 0, and in remainder theorem you know that to find the remainder you found f of a. So, f of a becomes a minus a into g of x plus, because x minus a is a factor, r is 0. So, what did we get? We have f of a is equal to 0. We have f of a is equal to 0. So, if a polynomial is divided by its factor, whatever the factor is given, then the result is that f of a is equal to 0. This is the result. Is that clear? If a polynomial is divided by its factor, then f of a is equal to 0. Here the factor is x minus a. So here it is given that when a polynomial f of x is divided by ax plus b, you know that the remainder is f of minus b by a. And if the remainder is 0, what it becomes? Ax plus b becomes the factor of the given polynomial. Conversely, if f of minus b by a is 0, ax plus b is a factor of f of x. Is that clear, children? So this is exactly what I have discussed a couple of minutes back, that f of x is equal to the divisor into quotient plus remainder. Now, in remainder theorem, and also I did tell you all that a polynomial can be denoted as f of x or as p of x. Here p of x it is shown. Okay. Now, we also learnt in the remainder theorem that if a polynomial is divided by x minus a, implies the remainder is p of a or f of a. Now here if x minus a is a factor of p of x, then r is equal to 0, and so p of a will also be equal to 0. How did we get to this condition? Look at this relation, that is the dividend, divisor, quotient and remainder. P of x is equal to q of x into x minus a plus p of a. Why did we write here as p of a, children? We wrote it as p of a because this is the remainder. But if this remainder is 0, it means p of a is also 0. Therefore, x minus a becomes a factor. It is like both ways. Okay. If p of a is 0, then r is 0, and so x minus a is a factor. Both mean the same. End of the day, children, what all you have to remember is that if p of x is divided by x minus a, implies the remainder is 0, and if x minus a is a factor of p of x, implies p of a is 0. That's all. Only these two keep in mind. Again I am telling, if p of x is divided by x minus a, it means the remainder is p of a, and if x minus a is a factor of the given polynomial, it means p of a is equal to 0. Only keep these two things in mind and learn to write these two statements when you solve the sums. Okay, let us see here also few examples before we go further. So here the first example. If f of x is 6x square minus 10x minus 4 is divided by x minus 2. They are asking us to check if x minus 2 is a factor or not. They are asking us to check if x minus 2 is a factor or not. How do we check whether x minus 2 is a factor or not? Come on, tell me, children. Just now we have learnt what is the condition for x minus a to be a factor. What is the condition, children? X minus a is a factor of the given polynomial if it is still here only, hiding here only, if p of a is 0. So, if p of 2 is 0 here, then x minus 2 is a factor. What is p of 2 and why only p of 2? As I mentioned, children, equate this x minus 2 to 0 mentally and you get the value of x. That value you have to substitute in the polynomial. So, p of 2 is 6 into 2 square minus 10 into 2 minus 4. 6 into 2 square, 6 into 4, 24 minus 20 minus 4, which is a 0. Therefore, x minus 2 is a factor. Is it not simple? So, is x minus 2 a factor of the given polynomial? Yes, it is a factor of a given polynomial. Now, before we go further into factorization, there are two very important concepts that you have to know. Not actually concepts, techniques you can call it, that is your algebraic division. Most of you have learnt about algebraic division in standard 7, how to divide a big algebraic expression by another. Okay, and now you will learn one more way of division which is accepted by the board, and that is synthetic division. It really goes very fast when you do synthetic division. Okay, so let's see both. It's not that you have to deny the first. If some of you are comfortable with long division, go ahead with long division, but I suggest synthetic division will save your time, far more time it will be saved. Okay. Now here what is the dividend, what is the divisor, what is the quotient we have to find. The dividend is x cube minus 2x square plus 0x minus 4. Why is this written as 0x? Because the polynomial, given polynomial was given as x cube minus 2x square minus 4. Now remember, I told you that the polynomials have to be written in decreasing order. So now this x term is missing, so we replace so that you don't make any mistake. Okay, the examiner is not interested in you to write the 0x as long as you do correct, but if we miss, we may lose a mark. So it's better always you fill in a missing factor with 0. Okay, so this is your given polynomial and we are dividing with x minus 3. So this is your dividend and the divisor is x minus 3. Always you have to check for the first term of the dividend and the first term of the divisor. X cube by x. You all know when you divide x cube by x, what do you get? You get it as x square. Now multiply this x square with the divisor x minus 3. What do you get? You get it as x cube minus 3x square. Write this x cube minus 3x square. Now here, if you remember in your smaller classes, you did subtraction and there was change of sign. Okay, there is the change of sign. So x cube minus x cube gets cancelled. Minus 2x square plus 3x square becomes plus x square. If you don't remember to change the sign here, there is a high chance of you to write minus 5x square and that comes to the downfall of your question. Okay, you will lose all your marks for this particular question. Be watchful, be careful. These are small places where you have to be really vigilant. So plus x square. Now since we have written here as 0x, we are safe, we are bringing down that 0x. Now again see the first term of this and the first term of your divisor. X square by x will give you what? It is x. Now you have to multiply this x with x minus 3 again. This is all your rough work, children. If you are comfortable doing it mentally, more than happy about it. So x into x minus 3 becomes x square minus 3x. So here it is x square minus 3x. Again here you have to subtract. So plus x square and minus x square gets cancelled. This minus 3 becomes plus 3. So 0 plus 3x is plus 3x and bring down the last term which is minus 4. Now again divide this 3x by x. 3x by x is what? It is 3. So 3 into x minus 3. 3 into x minus 3 is 3x minus 9. Again show the subtraction. Minus plus 3x becomes minus 3x. So they get cancelled. Minus 9 becomes plus 9. So you get 5 as the remainder. So this is the entire process of finding the remainder by long division. Now but in your exam, if they ask you find the remainder when this particular polynomial is divided by x minus 3, how will you do? Children, we have learned just now. So let's quickly apply our remainder theorem and let us finish this sum in how much time we took? We took a couple of minutes to do the sum. Of course, I was explaining, but really took time to do this sum. So if they ask us to only find the remainder, then we need not sit and do this long division, right? So what is our polynomial here? Our polynomial here is x cube minus 2x square minus 4. Here you need not even write that 0x because you are not doing actual division. So it is divided by, so this polynomial is divided by x minus 3, implies the remainder is p of 3. The remainder is p of 3. Now what is this p of 3? Children, I will just write here, please adjust. P of 3 is 3 cube minus 2 into 3 square minus 4. What is 3 cube? 27 minus 2 into 9, 18 minus 4. So 27 minus 18 minus 4. which is 27 minus 22. Is it not 5? So, how much time did we take? Yes. So, only to find the remainder you can use your remainder theorem. No, not can, you should use your remainder theorem in this particular lesson. But then ma'am, why should we learn long division then? You have to learn long division or you have to learn synthetic division because you will be asked to factorize the expression completely. Then you have to know how to divide. That is the reason you have to learn this division. At least you should remember that you have learnt it sometime back in standard 7. So, let us see this synthetic division now. Really simple children, synthetic division. Okay. So, synthetic division, if you have to see, here it is 2x cube minus 5x square minus x plus 3, and that is your dividend, and your divisor is x plus 3. Okay. So, as usual, equate x plus 3 to 0. What is the value of x? X is equal to minus 3. Keep that in your mind. Now, here in synthetic division, you will write the coefficients, not quotients, coefficients, C-O-E-F-F-I-C-I-E-N-T-S, the coefficients of each of the terms in the expression. So, and in decreasing order of their powers, that is in descending order of their powers. So, what are the powers here? X cube, x square, x, and x is power 1 and the constant term. So, the first coefficient is 2, the second coefficient is minus 5, the third one is minus 1, and the last one is a constant which is 3. You will write it as it is. Okay. Now, keep listening to me very, very carefully. Okay. Though the solution is there, but please keep listening to me carefully. Now, here you have first under 2 put a 0 or bring down 2 as it is. Your first step is, okay, 2 minus 5 minus 1 and 3. Okay, one second, this is not the, okay, yeah. So, I will just put, yeah. So, and here you have minus 3. Put a 0, bring down 2 like this. Minus 3 into 2 is what, children? Minus 3 into 2 is what? 6. Minus 6. Write this minus 6 here. Minus 3 into minus 6 is what? Minus, I am so sorry, minus 5 minus 6 you have to add. So, it becomes minus 11. Now, minus 3 into minus 11 is what? Plus 33. Now, 33 minus 1 is 32. So, minus 3 into 32 is minus 96, and if you subtract, if you add, you get minus 93, which is the remainder. I will again explain with the previous sum so that you understand better. Here, if we do synthetic division, how will it be helpful? Here, if we do synthetic division, let us see the difference. Oh, I selected highlighter. Yeah. Here if we do synthetic division, let us see whether we can work it out with synthetic division here. So, let us quickly see, we know what the answer is. So, if we get the same answer by synthetic division, it means that you have understood, okay. You will mentally do, though we are virtually connected children, you can mentally do along with me. So, what did I ask you all to write? I asked you all to write the coefficients of the dash of the dividend in what, which order? In decreasing order. So, here the coefficients are 1, minus 2, 0, and the constant is 4, okay, and the constant is 4, and x minus 3 equated to 0, so it is 3, put a 0 here. So, you have 1, 1 plus 0 is 1, 3 into 1 is 3, minus 2 plus 3 is plus 1, 3 into 1 is 3, again 0 plus 3 is 3, 3 into 3 is 9, and this is minus 4 is missing. So, minus 4 plus 9 is 5. Did we not get the same remainder? Did we not get the same remainder? We will get the same remainder children, And if you observe, this is really careful, you need not do this multiplication in your rough work, this, that and all you have to do is you have to write the coefficients of all the terms of the given polynomial, that is your dividend, in decreasing order along with the constant term. Write this x value which is 3 or minus 3 or whatsoever. Your first step starts with writing 0 under the first coefficient. Add 1 and 0, you get 1. Then you multiply 3 with 1, you bring it down to the next term. Now add again these two terms, write it down below, the answer as plus 1. Now 3 into 1, write here 3. Okay, again add this 0 and 3, you get again 3. 3 into 3, 9, minus 4 plus 9 is 5. Minus 4 plus 9 is 5. Is that clear between the synthetic division and long division? Yes, synthetic division and long division. So based on these two divisions, if you are comfortable still with long division, choice is yours, but synthetic division at all times saves your time, okay, without saying it is a time saver method. So please try to adopt to synthetic division now or later. So that comes to the end of factorization of polynomials. So in this video we have learned about what is factorization, what's a polynomial, what is remainder theorem, what is factor theorem, how to do long division and how to do synthetic division with couple of examples as well. So this is all about the basic fundamental concept of factorization. The next video, upcoming video, will be solving problems based on factorization of polynomials. Okay children, so that comes to the end of this video. We'll catch up soon with the next video on the problems from factorization of polynomials. Hope you have enjoyed this video thoroughly and you followed every single detail that I tried to explain in this video. Okay, follow the videos till the end children, don't watch in bits and parts, just like okay, some video notification has popped up, I will watch this. Don't do that. Any one person, any one coach, if you are following, follow all his videos, because you will get adapted to his or her way of teaching. That will be really useful to you. Okay, it is not about promoting someone or not promoting someone. Choice is yours, whomever you are trying to follow or whomever you wish to follow. Follow their videos and keep following them so that you get the pulse of how the person is teaching. You will get acquainted to that method and you will really resonate. Okay, so if the frequency matches between the coach and the student will start resonating. So keep this point in mind. See you back in the next video. Till then, stay blessed and don't forget to like, subscribe and share to ICSE MathGuru and hit the notification bell to get notified of the upcoming videos. Bye and take care.